Hi everyone and welcome to part 2 of Chris's Rubik's Cube displayed in a RGB LED rectangular prism. Here we're going to look at how to rotate and solve a Rubik's Cube in an LED prism. So we've got to get from this to this. If you haven't seen part 1 yet, I will put it in the links below. And hopefully we'll get enough likes for me to make a part 3. Here, I'd like to share some of the code required to display and solve a Rubik's Cube on an RGB LED rectangular prism. The first thing we need to decide is how are we going to remember where all the cubies have got to. There are 27 cubies that make up a Rubik's Cube, 26 visible, 1 invisible, and we need to track them. Not only do we need to track where each of the cubies are, we also need to track how they are now orientated. A quick Google search and I found a paper written in 1984 by Professor Howard Peel. He describes 7 different ways of describing a Rubik's Cube for a computer. Each of his descriptions also contain pros and cons for each of his methods. After careful consideration, I decided to use my very own bidimensional array. We needed an array of bytes that was 27 by 4, which gives us 108 bytes. And I could call this array Cube Array. So let's get orientated. The bottom layer of my Rubik's Cube are numbered from 0 to 8. What's important to understand is that this cube here is 0. It is also the 0 location of the RGB LED rectangular prism. Whenever you look up any of the guides on how to solve a Rubik's Cube for beginners, they nearly always tell you to orientate your cube in such a manner to have the white on top and the blue to the front, which is what we've done here. Okay, for those of you who are thinking about using some of this code on your own, you'll need to know my X, my Y and my Z in relation. So here is a developed view of a Rubik's Cube for reference. Just to make note, the little squares have 2 numbers in each. The top number represents the cubie location ID. This one here is the cubie location ID. And while the cube is solved, it happens to also be the cubie number as well. The bottom number, this one here, is in reference to X, Y and Z. A 1 is X, a 2 for Y and a 3 for Z. If we have a quick look at cubie 0 here, or here, we can see that they all have the same cube location, and because it's solved, they all have the same cubie ID number. However, they have a 1, 2 and 3 for the orientation. So the blue is in the X, the yellow is in the Y, and the red is in the Z. There is no number 13. However, I've decided to keep number 13 mostly for my head, because it's much easier for me to manage 3 layers of 9 than 2 layers of 9 and 1 layer of 8. So number 13 cubie gets to stay, even though it's invisible. Also, whenever I've been to any of the sites and people are showing you how to resolve a Rubik's Cube, nearly always they say, and you don't need to worry about the center cubies. That in this case would be one like 10, 12, 14, 16, 4 or 22. Well, it's true, those cubies do not move in relation to the Rubik's Cube, but they do move in relation to you, the RGB LED rectangular prism, or the world. So yes, I think you do need to track them, and anyway, in my program we do track them. Okay, getting back to the cube array. As I mentioned earlier, is a bidimensional or a 2-dimensional array of bytes. Why did I choose 27 for? Well, there are 27 cubies in a Rubik's Cube. And for each of those cubies or locations, we need to keep 4 pieces of data. The cubie that's occupying that location and its X, Y and Z. So, to start off, we need to populate that the array, and because we always start with a solved cube, we populate it using a loop where I here goes in here and in here. What this will give us is each location will have a cubie of the same number. It will also have an X, Y and a Z all orientated the way a solved cube would be. So here we're looking at cubie 18 in location 18, and we can see by here that it is orientated correctly because we have a 1, a 2 and a 3 in the X, the Y and the Z location. So what if we were to jumble up this cube? Well, here we have cubie 18 still in location ID 18, however our X, Y and Z's are no longer correct. If we were to query our cube array and look at cubie ID 18, we would see clearly there is cubie 18. However, we now have a 3 in the X, a 1 in the Y and a 2 in the Z, which corresponds to how the cube has been mixed up. Similarly, if we put cubie 18 in location ID 0 and query it, we would get a similar result. So here, let's have a look how we're going to update our cube array as we rotate the cube's layers. In this example, we're going to move the y-axis. We are going to move the top layer around the y-axis in a clockwise direction. I have written 3 subroutines for managing this. One called update array y, x and z. To do this, we need to also send 2 pieces of information. One, we need to tell it which layer of the cube that we're working with, and I've chosen to use the lowest cubie location number for that layer to do this. And the other thing we need to do is tell it which direction we want to rotate. 0 for clockwise and 1 for counterclockwise. So let's look at one of the subroutines for updating the cube array. This one is update array y. Obviously we're updating in the y-axis. When we called it, we already gave it 2 values, so k became 18 and dir is 0. We also need a couple of other variables for the job. Temp, which we'll use at the end, and move 9,4. Notice the number 9,4. That's because we are moving one level of a Rubik's Cube, which has 9 cubies, and there are 4 pieces of data in each of those to be moved. So 2 nested loops will do that nicely for us. So we're going to copy the information from the cube array to move that corresponds to the level that we're working on. Hence why we brought over the 18. So I will equal 0 in the first instance plus 18, so I equals 18. So we're working with the top level, 18 through to 26. Okay, once we've copied them over, we can now work in the clockwise direction. As I said earlier, we can now transfer in a predetermined order the new locations for each of the cubies. Notice that the X, Y and Z nothing's happened yet. They still remain the same. However, the cubie numbers have moved. So a quick example would be this cubie here is going to be here. This cubie then would have moved on. Okay, of course, if we're doing it in the clockwise direction, it's exactly the same process, except the predetermined values are slightly different. In fact, they're inverted from the other one. Okay, as I said, the X, Y and the Z, nothing has happened yet. So we need to come back and then go through and move in this particular case, our Z's and X's around. Because we're moving in the Y plane, only X and Z get inverted. So all the X's become Z and all the Z's become X. And that's what this component of our code does here. Okay, so now we know how we're going to track the cubies using our cube array. How are we going to find the cubies when we want them? Okay, so here we have cubie 18 in location 18. However, it is misorientated. So how are we going to find that? How is the program going to know where cubie 18 really is? Just keep in mind, this is cubie 0 is still down the bottom corner there, just for orientation reasons. Okay, well, we have another subroutine called find cubie. And in the brackets we have the number of the cubie that we're actually looking for. So cubie 18. Having a look at the code, because we started with the byte, when this terminates, it will return a value for us in bytes. Okay, so cubie 18, where are you? We start here, I will be 0. Now a while statement will continue forever or until the condition becomes true. So what we're saying here is while cubie array 0, 0 is not equal to cubie, increment I. And this will continue on until such time as the statement becomes true. So in the first turn, I equals 0, which is this cubie, I equals 1, this cubie, I equals 2, this cubie, I equals 3, this cubie, I equals 9, this cubie, 10, 11, 18. As soon as it reaches 18, the while statement becomes true, and this little function terminates, and we return the I, which equals 18, to the calling unit. So if we were then to print off the cube array 18, we would find out that the 0 value was 18, so we found cubie 18, and we'd find that the X was misorientated, the Y is misorientated, and the Z is misorientated, as it is in the diagram. And one final note about our cube array. As you've seen that several subroutines are going to either read or write to the cube array, it needs to be global. And to make it global, it must appear before any of the routines, the main routine or any of the subroutines that are going to call it. So you need to stick it right up the top of your code as it's demonstrated here. Thanks.